Hey y'all, welcome to Miss Clark's chemistry class. If you need help drawing Lewis structures for covalent and ionic, you are in the right place. That's what we're going to do. Now, if you are needing a lesson on how to draw these structures, I'm going to link a video up above. You need to start somewhere else. This is a mixture view for Lewis dot structures for ionic compounds and covalent compounds. Now, I am going to be doing more covalent compounds than ionic compounds. So get some paper, periodic table, and let's get started. Okay, so for our first example, we have SO2. We need to notice that sulfur is a nonmetal and oxygen is a nonmetal. This is a covalent bond. We need to show shearing. So the first thing we need to do is add up our valence electrons. Sulfur has 6 electrons. Oxygen also has 6 times 2, so that's 12. We have 18 total electrons to play with. Now we need to orient our molecule, SO2. Now, we don't have any rules about sulfur or oxygen. Now, most of the time, your least electronegative element is going to be in the middle, which is sulfur. Also, in chemistry, things are always going to be balanced. So we're going to have an S in the middle and an oxygen on either side because, again, symmetry. Okay, so now that we have it oriented, we want to bond everything with a single bond. Remember, each bond is 2 electrons, so we just used 4 electrons, so we are down to 14. When you start adding electrons, it is very important that you start from the outside and go in. So we're going to start with the oxygen. Right now, oxygen feels like it has 2 because of this bond right here. Bond is worth 2. Oxygen is attached to that bond, so oxygen feels like it has 2. So when we start adding electrons, we're going to start by adding the 3rd, 4th, 5th, 6th, 7th, 8th. We just used 6 electrons. We have 8 left. I'm going to do the exact same thing to this other oxygen because it's in the same situation. Now I have 2 left. Outside, in. The 2 are going to go to sulfur, but we've ran out. 0 electrons. Oxygen has 2, 4, 6, 8. It's good. This oxygen, 2, 4, 6, 8. It's also good. But let's look at sulfur. Sulfur has 2, 4, 6. Not good. It wants 8. We have ran out of electrons, and so we need to rearrange some of the electrons we already have drawn. So what we need to do is we need to take any 2 electrons from any oxygen, to be honest. Any 2. I'm going to choose these, and I'm going to move them here. So now I am going to have a double bond here, no electrons there. Let me redraw that. I'm going to have oxygen. I'm still going to have those 4 dots on oxygen. I'm going to draw that double bond. Sulfur, it had a lone pair. Single bond to oxygen. Lone pair, lone pair, lone pair. Let's check it this time. This oxygen has 2, 4, 6, 8. It's good. Sulfur has 2, 4, 6, 8. It's good. Oxygen has 2, 4, 6, 8. Also good. Sulfur dioxide, this is what we call a resonance structure because we have the double bond here in the first oxygen and the sulfur. But we really could also have it here. When you can draw a structure 2 different ways and it still be correct, that's called resonance. Let's do another one. Now I wanted to make sure include Bi3 to these examples because boron is kind of weird. Let's look at boron. Boron is in group 13, so it has 3 valence electrons. And it's a metalloid, so we're like, well, is this an ionic bond or a covalent bond? If we were to look at the electronegativities, we would see that this is a covalent bond. And since boron only has 3 valence electrons, it can only make 3 bonds. I know, boron, weird. So boron has 3 valence electrons and iodine has 7. 7 times 3, we've got 21, plus boron's 3, we have 24 electrons to play with. Now, we don't have a rule about boron, but we do about iodine. Iodine is a halogen, and halogens have to go on the outside. So I'm going to draw my eyes around my boron. Now I'm going to link everything with a single bond. That took 6 electrons, 2, 4, 6. So we have 18 electrons left. Now I'm going to go add electrons from the outside in. Outside and then in. So again, 2, 3, 4, 5, 6, 7, 8. I'm going to do that to all of the iodines. So each iodine needs 6 electrons. Okay, let's look at this one. BeF2. Now we need to notice Be, that's in group 2. That is a metal. Beryllium is a metal. Fluorine, a nonmetal. Very electronegative nonmetal. This is an ionic bond. We need to draw ionic bonds a little bit differently. First, we start with drawing the elements, giving it its valence electrons, group 2, 2 valence electrons. I'm going to change colors to do fluorine. Fluorine has 7 valence electron. It's a halogen. Now, fluorine really wants another electron, and since it's so electronegative, it's going to steal this electron. It only wanted 1. When it got 1, it now has an oxidation number of -1. Very happy fluorine is now. But we have beryllium here, still with this extra valence electron. And hey, y'all, I did give you a hint by giving you the whole formula, F2. It's going to take 2 fluorines to get this done. So let's put another fluorine with its 7 valence electrons. And then it will also steal an electron. So when we get done, fluorine, also a -1. Beryllium has had both of its electrons stolen. It becomes a +2. Ionic compounds are neutral. So we have a +2. If we add up both of our -1s, we have a -2. That's going to equal 0. BeF2, ionic bond. We use arrows to show transfer. Let's do another one. H2CO. All of these elements, hydrogen, carbon, oxygen, all nonmetals. This is a covalent bond. We need to count up the valence electrons first. Carbon has 4. Hydrogen has 1, but it's multiplied by 2. Oxygen has 6, so let's add that up. We've got 6 plus 4. That's 10 plus 2 more. We've got 12 valence electrons. Now, carbon is always central when it is given to us. Now, we have 2 hydrogens and an oxygen. Hydrogens have to be on the outside. Carbon has to be central. So I'm just going to put oxygen up top. Now let's put single bonds. And we just used 2, 4, 6 electrons. We only have 6 left. We've got to start from the outside in when we're adding our electrons to get 8. But remember, hydrogen. Hydrogen is happy making just 1 bond because it only had 1 valence electron. So both hydrogens are good. So we need to move on to oxygen because we're going outside in. Right now, oxygen has 2 electrons. So we're going to add 3, 4, 5, 6, 7, 8. There was my 6 electrons. I am out of electrons. Let's check carbon because I've not looked at carbon yet. Carbon only has 2, 4, 6. Carbon is not happy. It only has 6 valence electrons. It wants 8, but we're out of electrons. Remember, this is when we just redistribute the electrons that are already out on the table. It doesn't matter which pair of electrons from oxygen you take, but we need to take one and move it down to make a double bond. So we're going to end up having oxygen with its 2 lone pairs. It's going to be double bonded to carbon, and carbon is going to single bond on either side with hydrogen. Let's look at another one. Okay, so we've got 2 carbons, 4 hydrogens, carbon and hydrogen both, non-metals. This is a covalent bond. We need to show sharing. Carbon has 4 valence electrons, but we have 2 of them, so we've got 8. Hydrogen has 1, but we've got 4 of them, so that's 4. So we have 12 total electrons. Now, carbon is always central, and hydrogen is on the outside. When we have 2 carbons, we can put them side by side. Carbon likes to make chains. Each carbon is going to have 2 hydrogens. So I'm going to put 2 hydrogens. Remember, everything in chemistry likes a little bit of a balance. So if it can be symmetrical, the same on both sides, it's going to be. So I've got everything oriented. Now we need to put in the single bonds. Bond, bond, bond. Remember, hydrogens only want a bond, so all of our hydrogens are good. Let's count up and see how many electrons we used. 2, 4, 6, 8, 10. So I have 2 left. Now if I look at carbons, both of my carbons, this carbon, 2, 4, 6, this carbon, 2, 4, 6. Each carbon really wants 8. And I have the 2 electrons. They're just going to have to share them because both carbon needs 2 more electrons. Remember, shared electrons are a bond. So I'm going to add a double bond right there. Okay, let's look at another one. Y'all, I know this is a funky looking compound. We got carbons, hydrogens, and oxygens. Those are all nonmetals. This is definitely covalent. Besides, when you look at this, it looks like it's going to make a chunky molecule. Chunky molecules are always covalent. Ionic, always neat. Remember, carbons are going to go in the center, always. Hydrogens have to go outside. Oxygens are going to kind of get in where they fit in. Okay, now I know we've not counted valence electrons yet. We'll get to that in just a second. So we've got this CH3 right here, the CH3. That tells us that that's going to stay grouped together. So we're going to have C, and H's are going to surround it. There's our CH3. Then we're going to have another C, because carbons are always central. Now this next part, I know how this is going to look, so it's easier for me to orient it. We're going to have an O and an H coming off of this carbon, and then our second O is going to come off the carbon, this second carbon as well. Now, I would love to challenge you to pause the video right now, and since I've oriented all the elements for you, you count up valence electrons and place them in the right spot. Okay, press pause. Did you do it? Now let's go through and see if you did it correctly. Let's count up valence electrons. We've got 2 carbons. Carbon each has 4, so that's 8. We have 4 total hydrogens. Each hydrogen has 1, so that's 4 more. We've got 2 oxygens at 6 each. That's 12. 8 plus 12 is 20 plus 4. We've got 24 electrons to work with. We're going to bond everything with a single bond. That's a lot. Now let's count and see how many that was. 2, 4, 6, 8, 10, 12, 14. If we used 14 electrons, we've got 10 left. Now we know our hydrogens are good because remember hydrogens, 2 electrons, 1 bond. So let's start looking at, we need to stay outside. We need to stay outside, so this is where we must look next. This oxygen only has 2 electrons, so we need to add 3, 4, 5, 6, 7, 8. We just used 6, so we have 4 left. Now we're ready to go to the inside. This carbon, 2, 4, 6, 8, it's good. This carbon, 2, 4, 6, not good. This oxygen, 2, 4, not good. We've got 4 electrons left. We're staying as far outside as we can, so we're going to go to this oxygen. It has 2, 4, so we're going to add 5, 6, 7, 8. We're out of electrons. And we've not even looked at that other carbon yet, this carbon here. And when we do, we see that it has 2, 4, 6. We're out of electrons. We're not done because this carbon doesn't have 8, so we need to move some electrons. So I'm going to take these electrons off of oxygen and I'm going to move them and make a double bond. How'd you do? Were you successful? Let's do another one. The first element is calcium. That is a metal. That tells us right off the bat, this is going to be an ionic compound. But I'm going to be real honest with y'all. This is a challenging one. So challenging that I would never ask this on a quiz or a test, but I like to challenge you in your practice. Because if you can do challenging ones in your practice, quizzes and tests, breezes. Now, OH has a parentheses around it. That's telling us it's working together as a unit. And OH are both non-metals. So OH are going to bond together with a covalent bond. And then 2 of them are going to bond with calcium. Let's see what we can do with this. First, I'm going to start with the covalent hydroxide, OH. So if I'm thinking about one OH, okay, I'm just going to break it and do one OH. O has 6 oxygen. Hydrogen has 1, so I've got 7 electrons. Bond them together. Now I have 5. Hydrogen's good, so let's look at oxygen. It has 2, 3, 4, 5, 6, 7. I'm out of electrons. But remember, we've got a whole situation going on here. So I'm going to draw another one of those because we have 2. Okay, I'm going to change colors. Now we're moving on to the ionic part. Calcium with its 2 valence electrons. If we look at this OH, we are short 1 electron. It really wants 1 more electron. Because oxygen needs 8, it only has 7. And y'all, this little group of OH right here, it has an electronegativity strong enough to steal an electron from calcium. So hydroxide, OH, is going to steal this electron. That's going to finish up our Lewis dot for O on the OH. So the exact same thing is going to happen here. Now, since these hydroxides have 1 more electron than they are supposed to, they're going to have a -1 charge. And since calcium got both of its electrons stolen, it's a +2 charge. And so this is how we're going to end up with CaOH2. Kind of complex, I know. Now I'm ending, this is my last example, and I'm ending with another challenge that I won't ever ask on a quiz or a test, but I want you to accept a challenge every once in a while. This is an ion. We just talked about OH being an ion. OH actually has a -1 charge. We saw that a second ago. This is a polyatomic ion, a group of ions working together, polyatomic ion, with a -2 charge overall. Now we're just going to follow the same rules. Nothing is going to change. Carbon has 4 valence electrons, and we have 2 of them, so that's 8. Oxygen has 6 valence electrons, and we have 4 of them. 6 times 4, 24. Let's add that up. I've got 32, but this -2 means we have 2 more electrons than we should have. We're starting with 34 electrons, y'all. Carbon goes in the center when it is available. So we're going to put carbon in the center. And since we have 2 oxygens, we're going to give each carbon 2 oxygens. Now let's bond everything with a single bond. And that took 2, 4, 6, 8, 10. That took 10 of my electrons. So I am down to 24. We're going to start adding electrons from the outside in. I'm going to just pick a random oxygen. It already has 2, 3, 4, 5, 6, 7, 8. If I want to make all of my oxygens have 8 electrons, each oxygen is going to need 6 more dots. I have 4 oxygens, 6 times 4, 24. When I get done doing this, when I get done with this, I'll have 0 electrons. Okay, 0 electrons. All the oxygens are good because we just made them good. Let's look at carbon. Carbon has 2, 4, 6. Not happy yet. This carbon, 2, 4, 6. Again, also not happy. Anytime we run out of electrons and we're not done adding 8 electrons to everything, we just have to reshuffle. You can grab any pair of electrons off of oxygen and move them into a bond. I'm going to do it right here. So we're going to take away these electrons and we moved them and we made this a double bond. This carbon now has 2, 4, 6, 8. It's good. We need to do the exact same thing to this carbon. So I'm going to grab 2 electrons and I'm going to move them and make a double bond. Now, this is another resonance structure. We put the double bond here and here, but we could have had it here and here. We could have had it here and here. So it could be a little bit, they could be diagonal from each other. They could be parallel from each other. Resonance structures. Okay, y'all, I know I did not do all of the practice problems from our mixed review, but I hope I did enough that would help you get through all the rest of them. Until next time, bye, y'all.